Hey everybody, welcome back. Well, I hope you enjoyed the last trick problem because here we've got another one that has a similar flavor, but we solve it a bit differently. So you're going to want to check this one out. So here we have if sine of theta plus sine squared of theta plus sine cubed of theta is 1, we want to find cosine to the 6th of theta minus 4 cosine to the 4th of theta plus 8 cosine squared of theta. Well, in order to solve this, we're going to need the following tools. So we're going to need that classic Pythagorean identity, a bit of algebra, and a bit more algebra. Okay, so with that said, let's go for it. So of course we want to assume this and try to build a bridge and find out what this is equal to. So yeah, go ahead and assume that sine of theta plus sine squared of theta plus sine cubed of theta is equal to 1. Now we're trying to build a bridge to something involving cosine, so it'd probably be smart to subtract this from both sides and introduce a Pythagorean identity. So subtracting sine squared from both sides yields the following. So we've got sine of theta left on the left, and then we've got sine cubed of theta left on the left, and then we've got this 1 minus sine squared of theta. And again, we do that with the hopes of introducing cosine stuff. So on the left, I'm going to factor out a sine. I do that because that leaves me with something involving sine squared. And for this, I can replace this with 1 minus cosine squared. So introducing more cosine stuff with that Pythagorean identity. Okay, so yeah, this is exactly 1 minus cosine squared. So I can rewrite this. So 1 plus 1 from the Pythagorean identity, of course, will give me 2. So I've got 2 minus, looks like cosine squared of theta. And that's equal to cosine squared of theta on the right. Okay, so we want to introduce more powers of cosine. So it might be smart to square both sides. So if I square the left side, it means I'm squaring both factors, right? I'm squaring this factor and I'm squaring this factor. So that's going to give me, it looks like sine squared of theta times 2 minus cosine squared of theta, quantity squared. And if I square the right, I should have cosine to the 4th of theta. Okay, so this gives me another Pythagorean identity. That seems pretty strong because we want a bunch of cosine stuff there. Whoops. Okay, so that's going to give us the following. So we've got 1 minus cosine squared of theta. That seems very, very nice. Okay, so we've got a binomial here. Let's go ahead and square this out. So that's going to give me, it looks like 4 minus 4 cosine squared of theta plus cosine to the 4th of theta. That equals cosine to the 4th of theta. Okay, so it seems fine so far. And let's just expand this out. Again, we want to introduce some higher powers. So yeah, let's see what happens here. Okay, so expanding this out. So that's going to give me 4 minus 4 cosine squared of theta plus cosine to the 4th of theta. So that's expanding the 1 over all three terms, now the minus cosine squared. So it's going to be minus 4 cosine squared of theta. Looks like plus 4 cosine to the 4th of theta. That seems fine. And then it looks like minus cosine to the 6th of theta. And that's equal to, looks like cosine to the 4th of theta. Okay, so that seems pretty good. We've got some options here. So I'm thinking about taking, we could subtract these from both sides. So that's going to give me a 0. And then, oh, this is actually really nice. So if you look at our end result, we're pretty close here, aren't we? So these will combine. These are like terms. So that seems pretty nice. And so let's combine these, and then we'll maybe shuffle some things around and maybe do a multiplication. So yeah, so I've got this minus cosine to the 6 of theta, and then I've got this plus 4 cosine to the 4th of theta, and then with like terms that should be minus 8 cosine squared of theta. And then this constant, I can bring this to the other side by subtraction. So that's equal to minus 4. And if I multiply both sides by minus 1, it's going to give us our result. That's really nice. So it looks like cosine to the 6 of theta minus 4 cosine to the 4th of theta plus 8 cosine squared of theta is exactly 4. That's a cool problem. So if you like that problem, folks, don't forget to subscribe. A ton of trigonometry on the way. Pre-calculus, Calc 1, 2, and 3 material, linear algebra, and some neat proofs.